Question 1. We are given an inequality 2 minus 5x greater than 2 absolute value of x minus 3. In order to solve the inequality, we must find a set of values of x that satisfy this inequality. There are two ways to solve this. Either you solve this by looking at a graph or you solve it algebraically. Using a graph is so much simpler. Let's say this is the first graph, y1, and you have the second graph, y2. We need to find the values of x so that the graph y1 is above the graph y2. Now we consider the case the graph y1 is 2 minus 5x, and we have the graph y2 which is 2 absolute value of x minus 3. We can draw the graph y1 first. For the graph y1, let's see, here you have the x-axis and the y-axis. For the graph y1, the y-intercept is 0. So when x is 0, y is 2. So you have a y-intercept of 2. And when x is 1, we have y equals 2 minus 5, which is negative 3. So these are the 2 points that the graph passes through. We are 1, negative 3, and 0, 2. Let's sketch a graph that passes through these 2 points. It's a rather steep graph. So let's see, it goes all the way up here. And we have this y1 equals 2 minus 5x. For the second graph, we have y2 equals 2 absolute value of x minus 3. The absolute value graph is a V-shaped graph. You have x minus 3, meaning that the vertex is at the point 3, 0. When x is 3, y is 0. You have a point with coordinates 3, 0. Now, we just need to find another 2 more points. So we can let x to be 4. When x is 4, y2 is 2, 4 minus 3. So that y2 has a value of 2. We have a point with coordinates 4 and 2, so we have 1 point here. And because it is perfectly symmetrical, you also have when x is 2, y2 is 2, 2 minus 3, the modulus, which will give you a value of 2. You have a point 2 with coordinates 2 as well. That will give you the V-shaped graph. So we join these 2 points and then, yeah. That is the graph y equals 2 absolute value of x minus 3. Now, for a modulus graph, when you remove the modulus sign, this part of the graph, this branch here, has equation y equals 2 times x minus 3. And the left branch has the equation y equals negative 2 times x minus 3. Let's look at the points of intersection. So these 2 graphs intersect at these points. We cannot look at the x value here. So let's say this is the x value, x naught value that we want. To the left of this point here, the graph y1 is above the graph y2, and to the right of this x value, the graph y2 is above the graph y1. So as long as we can find x naught, we can find the solution to the inequality. The solution to the inequality will be value of x less than this value. So to the left of this x naught here, the graph y1 is above the graph y2. We need to find the point of intersection of these two graphs. y1 is 2 minus 5x. y2 in this case has equation negative 2x minus 3. 2 minus 5x is negative 2x plus 6. When we rearrange, negative 2x plus 5x is 2 minus 6. We have 3x equals negative 4 and x equals negative 4 over 3. Then the solution to the inequality will be x less than negative 4 over 3. Question 2. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying the two inequalities. The first inequality, we have modulus of z greater than or equals 2. Modulus of z greater than or equals 2 would be the region outside the circle with center at the origin 0, 0 on the Argand diagram, and the radius is 2. So you have the center with origin 0, 0, and the radius is 2. And for this case here, absolute value of z minus 1 plus I less than or equals 1. We can write this as modulus of z minus 1 minus I in a standard form. So this part 1 minus I will give us the center of the circle. We look at a circle and the center in this case is 1 negative I on the Argand diagram, and the radius is 1. So we need to sketch the axis for the Argand diagram first. We have the imaginary axis and the real axis. So the first circle here, center at the origin. This is the origin with a radius of 2. So we draw a circle with a radius of 2, center at the origin. That is 1, 2, negative 1, negative 2. And then we have I, 2I, negative I, negative 2I. So we need to look at area greater than or equals to 2, then the area must be outside this circle. The second one, we have a circle with center 1 and negative I, that is the center, and then the radius is 1. So we draw a circle with radius 1. So that should give us a circle with radius 1. So that is a circle with radius 1. And for this circle, we want area inside the circle. So the intersection of these two areas is this part here. This tiny area is what we want. That is the solution that we want.